Today we're doing note 37, anti-differentiation by substitution. So a lot of this is called U sub because that's the letter they use to substitute. So if you're at the university, if you're looking at my YouTube channel right now at the university, it's called U sub. If for those that are viewing my channel right now at this moment, not you guys. All right. What's the difference between an indefinite integral and a definite integral? All this means is this integral is defined. So a definite integral means you have limits on the upper and lower and upper of your integrand symbol. So this is a definite integral. And an indefinite integral means you do not have limits. Now, hopefully you remember that whenever you do the antiderivative of an indefinite integral, you put the plus c label. Simple, right? Okay.
Wait, what?
You put the plus c?
Whenever
Yeah.
we're doing like the
Indefinite. Yeah, like you'll see, look.
You do like the antiderivative plus.
Yes, because there's no limits. So look at this one. Number one, you guys already know how to do this. What's antiderivative of x squared? Yeah, I like to write it as x cubed over 3. 1/3 x cubed is the same thing. What's antiderivative of sine? Yeah, cosine. Positive or negative? Yeah, so the derivative of sine is cosine, but the antiderivative of sine is negative cosine. So it should have been plus cosine x and then plus c. And then here's how you test it, guys. You always got to put the plus c. Always, always, always. If you take this derivative, do you get this expression? Well, the derivative of x cubed over 3 is x squared, and the derivative of cosine x is negative sine. And there it is, and the derivative of constant is 0. So it works. Check mark. Cool or not cool? All right. Now, here are some properties of integrals. I think I already gave you a copy of this, guys, but here's another one. This is coming from the Demana textbook, which is supposed to be the textbook that we're using. So it says see example 2. Well, no, I didn't, copy that example from the Demana. But there it is. And I think when we come back next week, I'll give you a whole bunch of lists of more. This is missing the inverse trig and all that, but no big deal. All right, here we go. Ready? So this is saying paying attention to the differential. Relax, don't freak out. All that means is that we're paying attention to what we're integrating with. The dx, the du, the dx. Do you guys see that? So we haven't done anything crazy, guys. So look, it says that f of x equals x cubed plus 1 and that u equals x squared. Find each of the following antiderivatives in terms of x. So they want to find the antiderivative in terms of x. So this one here means integral. F of x is x cubed plus 1. So x cubed plus 1 dx. It's up to you if you want to put a parenthesis around the x cubed plus 1. Doesn't matter. We're good to go. We're just taking the antiderivative. What's the antiderivative of x cubed? Perfect. What's the antiderivative of 1 with respect to x? X. And then I put a plus c. We're done. That's the answer. Cool or not cool? Okay, this one has an fu du. That means I'm taking the derivative with respect to u, but it tells me that it's f of u. I got to be careful not say fu because that's like, okay, anyways. So f of u, not fu, but f of u is plug in the u into your expression of f of x. U cubed plus 1. Are we okay with that? That's what I'm going to take an antiderivative of. What's up?
So whenever we have since we're looking for the antiderivative for x, are we always gonna plug u in, or will we ever do the other where we plug in the x?
I don't even know what your question is because you started initially with something and then you jumped to something else. Okay, say it again.
Okay, so are we always gonna plug in? Are you always gonna plug in u for x or?
Oh, got it. We can plug in any letter for x. It doesn't have to be x. This is just an expression or an equation. It says f of x equals x cubed plus 1. We could have said f of happy face equals happy face cubed plus 1. It doesn't matter. F of triangle cubed plus 1. It's just, you know what I mean? Okay, did I answer your question? Yeah. Okay, so there it is. Now notice that this says that I'm integrating with respect to what letter? U, and I already have it in terms of u. So antiderivative of u cubed is u to the 4th over 4 plus, not x, u plus c. There it is. Now, that's not what this says in the top. It says find each of the following antiderivatives in terms of what letter? X. And they told me that what does u equal? X squared. So I'm going to plug in. So I'm going to say u equals x squared. So every time I see a u, I'm going to plug in a what? An x squared. So here's what I have. X squared raised to the 4th over 4 plus x squared plus c. Is everyone okay with that? All right. So now I'm just going to figure out this math, laws of exponents. An exponent raised to the exponent, that's going to be x to the 8th over 4 plus x squared plus c. We're good now. Happy face. How do we feel? Okay. Now look. Okay, I'll wait. Did everyone good? Okay. I'm trying to slow down and listen to you guys and all that good stuff. Am I going okay? Awesome. All right. Notice this one, letter C, says that I want the antiderivative, but it doesn't want it in terms of u. It wants it in terms of x. So first, on the side, I'm going to go f of u equals, and what does f of u equal? U cubed plus 1. Are we still okay? Now, remember that we said what u is. U is, well, u is a star, but u is equal to x squared. Yes or no? So, that's what I'm going to plug in for this u here. So, this is x squared to the 3rd plus 1, which equals x to the, what's 2 times 3? 6 plus 1. This is my f of u statement right here in terms of x.
But why did we?
Because it says f of u dx. This is f of u. And then I plugged in, this is like a composite argument, almost like a composite function, f of g. So u is x squared. So in terms of x, it's going to be x to the 6 plus 1.
Yeah, but why are we plugging in x?
Right here. Why are we plugging in x? Because this wants me to integrate with respect to x.
But like there, we didn't plug in x until after.
Correct, because this one wanted me to integrate with respect to u. The question in the very...
The derivative in terms of whatever letters after.
No, well, no, because I'm answering their question. It says all the antiderivatives in terms of x. So they don't want to see any u's. They want everything in terms of x. On the first one, it was everything was in terms of x, so it's an x. On the second one, everything was in terms of u. I did the antiderivatives in terms of u, and then because I had u's, I didn't want u's, I wanted x's, I put the x. On the third one, it wants me to take the derivative with respect to x, but they put f of u in there. This is my expression in terms of u's. I turned it into x, and now I'm about to take an antiderivative.
So you take the antiderivative based off of like the letter that's after.
You take the antiderivative based off of that. That dx means take the antiderivative with respect to x.
Okay.
Here we go. Integral x to the 6 plus 1 dx. It's up to you if you want to put parentheses like that. That's fine. What's antiderivative of x to the 6? X to the 7th over 7, or 1/7 x to the 7th plus x plus c. Let's put an equal sign. There it is. Done. How do we feel so far? Okay. So I think we're pretty good. Okay. No, that's a demerit, miss. No more yawning. No, you're good. You're good. Okay. So let's add more tools to you guys because you guys are really smart. But now, some of you do not need u sub. You can probably see it. You can probably look at this. It says antiderivative of sine x e to the cosine x dx. You don't need to do u sub for everything. If you see the chain rule, like if you see like, oh, when I take a derivative of e to the cosine x, that's e to the cosine x times negative sine x. Oh, look, there it is. If you see it, you can just type it in. It's going to be a negative in there. If you don't see it, you have to make a relationship. Not like a relationship like, say, hello, how you doing? My name's Omar. What's your name? Like, not that type. That's dumb. Yeah, sorry, no, my jokes are lame today. A relationship as in, how is cosine and sine related? Well, if you take the derivative of cosine, won't I get sine? So here's how you do it. I'm going to rewrite this. I'm going to rewrite it like this so it's easier to see. Integral e to the cosine x times sine x dx. Are we okay? And then I'm going to say this. I'm going to say u equals cosine x. And we'll tell you why in a little bit you couldn't make u equal to sine x. U equals cosine x. What is the derivative of u? What is the derivative of u with respect to x? Negative sine x. Okay, from now on, instead of, because this is going to take time, not that it takes a whole bunch of time, instead of writing du dx equals negative sine x, I'm going to write it like this. I'm just going to go du equals negative sine x dx. Is everyone okay with that? Notice I have a sine x dx right there. It almost looks like this one. The only difference, it doesn't have a what? Negative. So I'm going to put a negative in there. If I put a negative in there, I got to balance it by putting a negative on the outside. Are we okay? Tell me, Gonzalez. Dime. No, it's all good. Hit me up. Yeah, this is the way I do it. Some textbooks don't do it this way. Let me tell you why. Because I'm going to be substituting. You see how I have a negative sine x dx right here? I have a negative sine x dx right there in underline. And all that just equals what? Du. But look what I added. I added that negative. I put that in there. So if you put that in there, you got to balance it. You put that negative in there, so you got to put a negative on the outside. Does that make sense? So now look what I have, guys. Negative on the outside, integral. E. What did we say u was? E the cosine. So e to the u, and look at this, du. Is that way easier to evaluate?
Yeah.
Yes. What's antiderivative of e to the u?
Du dx.
No, just antiderivative of e to the u with respect to u.
Oh, e to the u.
E to the u. Put the negative in the front, e to the u, and put a plus c. Don't worry, we'll fix it right now. Now, remember, we didn't find that the original expression was not to take the antiderivative of the u. They're equivalent. The original expression was to take the antiderivative in terms of x. So all I got to do is plug in back what u is in terms of x. What was u? No, that was for the previous one. Cosine x. So my new antiderivative, the final one, I guess you can write it like this. The integral of sine x e to the cosine x dx is nothing more than negative e to the cosine x plus c. And I'll wait for you guys to catch up.
Yes. Sorry.
What happened to the what? Oh, the du or dx, that just means to take the antiderivative with respect to it. So it goes away. It's just this. F of prime x dx, it just equals f of x plus c. See? Well, no. When you take the antiderivative, that dx has to be there. That's just your delta x. But remember, the fundamental theorem of calculus just states, if I take the derivative of f prime of x, you just get f of x. Or if I take the derivative of f of x, you just get f of x. FTLC, ddx of some constant a to x up here, f of t dt is just going to be equal to f of x. So remember that, because of that, we just drop the dx. You just drop it. You're just doing antiderivative of your expression. Okay. All right. If you want to verify that it works, look, guys, now I'm taking derivative. If I take the derivative of this expression, you better get this in parentheses. The derivative of negative e to the cosine x is itself negative e to the cosine x times the derivative of cosine x, which is negative sine x. So negative times the negative is a, and do I get sine x e to the cosine x? Yes. What's up?
You had said a couple sentences back that you were going to say what do sine x.
Correct. That's what I was about to get to that. Okay. All right. So what if you would have chosen the wrong one? Because what if you would have been like, well, cosine x and sine x, I can just as easily take the derivative of sine x and get cosine x. So don't write this down. Just listen. Because this will happen a few times, but then you get better with more experience. You would have said u equals sine x, and then you would have gone du is equal to cosine x dx. And then you would have said, oh, okay, do I have a cosine x d? Remember, it has to be paired together. Do I have a cosine x dx paired right here like that? No, there isn't. So you would have been like, well, I can't do that. Then it has to be the other way around. Does that make sense? So you got to figure out what u is. And it's really simple. Well, okay, it's really, you know what u is, but it's really simple to figure out what this u is this math one, because of math, because of the relationships. When you take a derivative, doesn't the degree just go one lower if it's a polynomial? That's going to be the most common. So look at example 4. So you're looking at it and you're like, Chav, I don't know how to do the antiderivative of this. It's complicated. Then you think about it like, well, I know u sub. And then look, in the inside of the square root, I have a third degree. Look what you have on the outside of it. A second degree. So in your head, you should be like, if I take a derivative of something with the third power, you get a degree less. So more than likely, u must be the inside of this. 5 plus 2x cubed. Does that make sense? without the square root, because we're trying to evaluate. We're trying to make this simpler. Don't worry, Gonzalez. I'm gonna show you why. All right. So that's the hardest part, choosing the u. When I take the derivative of this, look what happens. Du equals the derivative of 5 as a constant. I get a 6x squared dx. Does everyone know where that dx came from? I did du with respect to x. Du dx. The derivative of 2x cubed. Derivative of 2. Okay. Are we okay? So here's what you should notice. If I rewrite this so you can see, let me rewrite it so you can see it a little simpler. 5 plus 2x cubed, and I'm going to put x squared dx. And I know I told you you can put parentheses, but all of this is a product, so it doesn't matter. I'm going to put parentheses like right here like that. Just so you can see. I would never really do this on an AP exam, or any exam for that matter, just for the notes. Do you see how I have an x squared dx right there, but the only thing that's missing is a 6? So in chemistry, if you have, I don't know if you remember chemistry, but if you have 6 oxygens on the right-hand side of your equation, you need 6 oxygens on the left-hand side of your equation. That's exactly the same thing I'm doing here. If I insert a 6 right here, I need to balance it. If I put a 6 right there, what do I put on the outside? Not a 6, a 1 6. Does that make sense?
Because it's
1 6 times 6 is 1, so it's balanced, perfectly balanced, like all things should be, like Thanos says. Okay, not that Thanos is a good guy, but what's up? Ask. Oh, I didn't put a negative because I didn't get a negative here this time. Oh, yeah, but on this one, when I took the derivative of cosine x, I got a negative sine x, and I needed to put a negative. I inserted a negative, so I put a negative on the outside. Yeah, because I need it to be equivalent. You know what I mean? And to the original, so make sure that like if you add something, whatever you put on the outside, you still needs to be the same. So make sure that you get like a 1. If I put a negative on the inside, like negative 1, it's like putting a negative on the outside. Negative 1 times negative 1 is still 1. If I put a 6 on the inside, I got to put a 1 6 on the outside. 1 6 times 6 is still 1. Does that make sense? Okay. All right, guys, here we go. Ready? Here we go. I'm going to write 1 6 integral, and all I'm going to have is square root of u du. Do you guys see that? Now I'm ready to take this antiderivative because it's way simpler now. Antiderivative, okay, let me rewrite it for you guys to see. 1 6 integral u to the half du. All right, now you can see it's real simple. So I'm going to write 1 6. I'm going to leave some space, or if you want, you can put it in a bracket. Antiderivative of u to the half is u to the, add 1 to the half, 3 halves, divided by 3 halves, which is the same thing as 2/3. And I guess I can put the plus c here if you want. Distribute the 1 6. When you multiply a constant by 1 6, is it still a constant? Yeah, so just write plus c. There's no need to write 1 6 plus 1 6 of c. Just write plus c because it's still a constant. So write it like this, guys. We're going to write 2 goes into 6 3 times. So 1/3 times 1/3 is 1/9. U. Okay, well, we'll rewrite the u in a little bit. U 3 halves plus c. And then I don't want it in terms of u. I want it in terms of x. So here we go. My final integrand, I'm going to write, so the integral of x squared cubed, square root of 5 plus 2x cubed dx is nothing more than 1/9, and then parenthesis 5 plus 2x cubed to the what power? 3 halves plus c. That's it. Leave it alone. You can do square root of that cubed if you want it. Okay, say that again.
Can you show us like what would have happened if we used the wrong u?
Well, if you would have done like, let's say you would have said u has to be 6x squared, you would have been stuck, see? You would have done du equals 12x dx, and then like, there's no 12x dx. See? What's up?
Is there any way we could find? Never mind.
No, ask.
Because I think the answer is no. Is there any way that we can find c value? No, because it's like
I don't have any limits, and I don't give you. I don't. Well, if you had limits, you wouldn't have a C. But I got to give you an initial condition.
okay.
Don't worry, we're going to be doing them with limits, definite integrals, but that's going to be on Monday. All right, ready, guys? So we have this one using substitution, cotangent 7x. You can probably look it up in an integral table, but there is no, so you're like, I don't know, I'm stuck now. Break down cotangent into what over what? Cosine 7x over sine 7x. Put a dx like that. All right, so then you think, what can u be? Am I going to make u equal to the cosine 7x, or am I going to make u equal to the sine 7x? Okay, let's don't write this down. Don't write this down. So let's say I made u equal to cosine 7x. Cosine 7x. So then I'm going to write du equals, what's the root of a cosine? Negative sine 7x times, well, yeah, but chain rule, times 7. So it would be negative 7 sine 7x dx. And then you come back here and you're like, wait a minute, can I replace the du with all that? No, you can't, because the sine 7x is in the bottom. This is like dx over 1 if you want to be technical about it. Do you guys see that? So that means that I got to try another one. Then it has to be what? Yeah, u has to be sine x. Oh, I erased a little bit of the top. That's fine. That's fine. That's fine. All right, so here you go. U equals sine 7x. Du equals, what's the root of a sine? Cosine, yeah. Cosine 7x times 7 dx. All right, so 7 cosine 7x dx. Are we still okay? So now here we go. If you have colored pencils, it is a good one for colored pencils. I almost have I almost have this, but I don't. What do I need to insert? 7. If I put a 7 right there, what do I put on the outside? 1/7. There it is. I like the chemistry route. If you look at some YouTube videos, they probably do it a different way. It's all the same, guys. So here we go. I'm going to write 1/7 integral. Sorry, there's a huge delay here. 7 cosine 7x dx is all equal to du. So I'm going to write du over u. Now you can do the antiderivative. I don't know if you recognize it. Do you recognize it? Here, I'll write it where you guys will recognize it. 1/7 integral 1 over u du. Now do you recognize it? It's an ln. Since it has no limits, put an absolute value. So this is 1/7 ln, absolute value of u, because remember the domain of ln is all positive numbers, but it has no limits. It could be negative. So you got to put an absolute value. Plus c. Are we still okay? All right, so we got our final answer, guys. So here we go. Here's how we're going to write it. We're going to write it integral cotangent, because the domain of ln of x is all positive numbers, but 1 over x is all real numbers except 0. So if I'm going to do ln, it has to be an absolute value so I can catch all the domain. The domain of this is all real numbers but 0. The domain of ln is just positive numbers. But if I put an absolute value, I catch all of them. Okay. Antiderivative of cotangent 7x dx is equal to 1/7 ln, absolute value. And instead of writing the u, I'm going to write what? Sine, not just x, but 7x. Sine 7x, close it, plus c. Yeah, ask.
Why does the 1/7 get carried to the c?
What do you mean?
Because wouldn't it be 1/7 brackets?
Oh, times 1/7 times the constant is still a constant.
Okay, so it's that plus c. Okay. It wouldn't be
All right, now we're getting, I guess technically it's getting harder, but I think it's okay. What's up? Your professor might count it wrong. Your professor would probably count it wrong. I mean, you're right, it's 1/7 times the constant, but it's still a constant. Like, I mean, you won't see, I don't think you'll see any calculus book that will have that 1/7 c. You know what I mean? Because it's a constant. So they just put C. I don't know, prove me wrong. Find a calculus book that shows that. Like, I don't know, because I haven't seen it. I've never seen it. It might be, or it might just give you like a side note and it's like 1/7 times C is still a constant, so just put C. It might have something like that, but no, it's just a constant, so leave it alone. All right. Are we cool? All right, it says, example 6, setting up substitution with a trigonometric identity. Find the indefinite integrals. In each case, you can use trig identity to set up a substitution if you need it. You don't need it. For this one, you probably don't need it, but we'll see. I look at it and like, I can't do antiderivative of that, but 1 over cosine is the same thing as secant, so this must be secant squared of 2x dx. This one's probably a perfect example where you might not need it. Yeah, what's the antiderivative of secant squared? So look, let's do it without it, and then we'll do the substitution if you feel you need it. So I see secant squared, and I'm like, oh, that's tan. And I got to keep that 2x, and then I put plus c, but don't worry, we're not done yet. Then you say, if I take this derivative, do I get secant squared 2x? Let's see, derivative of tan 2x is secant squared 2x times 2. Is there a 2 there? So how do I make sure that 2 is not going to come into existence? Put a half. Do you see how we did it? All right, now here it is with u sub. If you wanted, you could have said this is, again, I use that as an S, my bad, sec squared of 2x. And I could have come to the side and I could have said u equals 2x. And then I go du equals 2 dx. I don't have a 2 dx, so I make it. I put a 2 right here, and I put a 1 on the outside to balance it. There is my 1/2. So then, look what I now have. I have 1/2 integral secant squared, I did it again, secant squared of u du. Antiderivative of secant squared u is tan, bless you, tan of u plus c. And then I plug back what u is, 1/2 tan of 2x plus c. And look, you get the same thing. Maybe this is one where you don't need the u sub. Maybe the u sub makes it harder. How do we feel? By the way, last week, I was trying to remember. I just replied yesterday. I know it was so bad. I need to get better at replying. Last week, one of your peers texted to see how to do one of these questions because she's in Cal 2. And all they're doing is like a whole bunch of trig substitution. And I just replied back with an answer yesterday, but she probably needed it last week, but I didn't have time, you know? But yeah. I just didn't have, but no. I mean, if you guys text me, I'll probably reply sooner. Not that I'm saying that once you graduate, I reply way later, but it's just like, you know, I got to take care of business. You know what I mean? Like. So don't get offended, guys, if I don't reply. Yeah. Stop. I'm sure if you start calling up last year's peeps, you can probably figure it out. But all right, here we go. Integral, stop. So I have integral cosine cubed x dx. Can I take the antiderivative of that right off the bat? No, but we can break this down. Let's see. Break this down into cosine squared x times cosine x. There's a reason for it. So why did I do that? Do you remember the Valentine's formula? Yes. What's the Valentine's formula? I really hope you take advantage of that formula one day for Valentine's, and if they don't get it, upgrade, break up with them, you know, find yourself a new boy or girl or whatever. Okay. No, I'm kind of serious. I mean, joking, but kind of serious. If they don't know cosine squared plus sine squared equals 1, like, get yourself someone that's cultured. Okay. Here we go. I'm going to substitute cosine squared with 1 minus sine squared. So I'm going to integrand. I'm going to write 1 minus sine squared x, close it, cosine x dx. Am I still okay? And now it's a lot easier. Now you can do u sub. Now I can do u sub to help. How are sine and cosine related? the derivative. Awesome, the derivative. Notice, look, they're making it perfect for me. I already have right there cosine x dx. That's the plan. I need to get du to be cosine x dx. So that means I'm going to write u equal to sine x. And I know you're saying, like, Chop, how is that going to make it easier? Look, if u is sine x, du is cosine x dx. In case you're wondering, which I hope you guys know, isn't that the same thing as saying sine x and in parentheses squared like that? Okay, so look, u is just sine x, du is cosine x dx, so here's my integral. Integral, parentheses 1 minus u squared, close it, du. Isn't that? Where's what from? Don't ask, it's all good. No, it's all good. Okay. The cosine x dx I substituted with du, right? And then the sine. Oh, well, from the Valentine's formula.
No, well, not the Valentine's Day formula. I've seen like 1 minus u squared. It's probably in.
All right, ready, guys? We're done. Look, what's the antiderivative of 1 with respect to, not x, but with respect to u? U. Minus, what's the antiderivative of u squared? And I got to put a plus c. So here's what it means. This means that the integral of cosine cubed x dx is nothing more than sine x minus sine cubed x over 3 plus c. Done. Cool or not cool? Yeah, that's it. I think that's it. All right. Look, don't worry. We need to practice. That's all we're going to do today, guys. The next half of this is definite integrals. We're going to continue that when we come back on Monday. Stop. So on number 3, I'm going to go u or du equals negative 3r squared dr. Notice that I have a 9r squared dr. Do you guys notice that? Isn't negative 3 times negative 3 9? So I'm going to pull one of these. So I'm not balancing on this one. This one, I guess kind of like balancing. So I'm going to go negative 3 integral. And I'm going to write negative 3. I'm just rewriting it. I haven't substituted anything yet. I'm just rewriting it so you guys can see. They already put the dr. Are we okay? Okay. Now notice du is equal to negative 3r squared dr. So there's where my du is going to go. So this is equivalent to saying negative 3 integral du over square root of u. Do you guys see that? Yep. And by the way, about the du's, because it is a common mistake for people to write like du in the front or something like that. The du always goes in the end, in the very back. And I know right here, like, well, you're right there, you put it in the top. It's because it's okay, right? But it's common. But I guess the better route is to do that. You always put the du in the back like that. Because the du signifies the end of the integrand. Cool or not cool, guys? All right, can you guys take it from there or no? Okay. Okay. So here's number 4. They tell me what u is. And I'm going to go real slow. So I'm going to write du equals 4y cubed plus 8y. And don't be careful. I know some of you are just tempted to just write dy. But when you write that dy, make sure to put a parenthesis like that. Do you know why or no? Yeah, because in reality you did this. And in reality you did du dy. So you took the derivative of u with respect to y. And then times y. So then all that times dy like that. Does that make sense, guys? Okay. So then you're here and then you look. So I'll go slow. Are we still okay? You look and you're like, well, that doesn't look like anything. But then notice there's a y cubed plus 2y right there. And notice I have a y cubed plus 8y. I can make this look like y cubed plus 2y. All I got to do is factor out a what? A 4. So now I'm going to write du equals 4, open parenthesis, y cubed plus 2y, close it, dy. So here it is. I'm going to take my colored pencil and I'm going to go, well, here's my y cubed dy. All it's missing is a 4. Well, look, I have an 8 right here. That 8, I can break it down to 2 times 4, yes or no? So I'm going to pretend that that 4 is right there, like that. So then I can just put this 2, it's just a constant. I can put that 2 right in the front of that. All of that is being multiplied. So I can just put the 2 there. Are we okay? So here we go. Here's what I have. I'm going to go slow. 2, parenthesis, and I have parenthesis y to the 4th plus 4y squared plus 1. I'm just rewriting it. Times 4 parenthesis y cubed plus 2y dy. Once you get to boss level, you don't have to rewrite it over and over. You can just see it and just do it. But look, this right there is just du. Do you see that, guys? And then so I can rewrite this. So here I am. I'm going to write everything in terms of u now. I'm going to write 2 integral. This is my du. Yeah, that's my du. And this guy is my u. What square? Oh, yeah. It's still a squared. So squared. It's u squared. Are we still okay? Yeah. Sorry. That would have been I would have gotten the wrong answer. All right. So now look, is this a lot easier to do now? What's antiderivative of u squared? U cubed over 3. Perfect. Plus c. Notice I put some space in there and I put a little dot. So that's 2/3, right? So I'm gonna write 2/3 u cubed plus c. And I'm gonna write back what u is. I know it sounds a little funny, but so here we go. I'm gonna write 2/3. And then parenthesis, what was u? Yep, y to the 4th. I heard someone say it. All raised to what power? 3. And you're done. Those are the probably like the toughest ones, maybe. You just got to be able to see patterns, like how are they all related. What did we learn last week? U substitution, right? Yes. For indefinite integrals. Yes. Now we're going to use U sub for definite integrals. Okay. Now this is true in math life and in life. Once you go to the letter U, you're not going to go back to X. Don't go back to your X. There's a reason why they're X's, guys. I'm being serious. I'm being very serious. Like, there's a reason why they're X's. Leave them in the past. Move forward. Keep moving on. It didn't work out. That's it. Let it go. The future keeps moving. So don't mourn about a relationship that failed because it didn't work. That's it. Just keep going. All right. So here we go. So the whole point, you see this integral right here, it says 0 to the power over 3 of tan x secant squared x dx. The whole point of u sub is to make an equivalent integrand and makes life easier for you. That's the whole point of it. So you look at it and you're like, if you can see the chain rule, then maybe u sub's not necessary. You can go ahead and take the antiderivative and then do upper minus lower. If you can't see it, then just use u sub. I would always use u sub. So I see tan x and I see secant squared x, and immediately I start thinking about a relationship between tan and secant squared.
Secant squared is the inverse.
No, don't say inverse. Secant squared is the derivative of tan. So when I take the derivative of tan, you get secant squared, right? So that means u is going to have to be tan x. Let me go ahead and make this little font a little lighter because it's, there we go, 1 point. All right, so here we go. Du equals, what's the derivative of tan x? So secant squared x, and then I put a dx on it. Are we okay? I see a secant squared x dx. I see a tan x. So I'm going to write integral u du. Notice that I have not written the limits. That's because now I'm in u. I'm not in x's. So here's what you say. When tan is 0, what is u? You're observing this one right here, guys. What is tan of 0? Uh-oh. Tan of 0. 0. And then you think, okay, when tan is pi over 3, what is u? Pi over 3 is way up here. Square root of 3. Remember that tan is y over x. At pi over 3, that's a half, comma, square root of 3 over 2. So square root of 3 over 2 divided by half is square root of 3. Are we good? All right, that's it. Do not go back to your x. That's it, guys. We're done. Antiderivative of u. What is it? Antiderivative of u? U squared over 2. Perfect. And I'm going to evaluate this from 0 to square root of 3. There is no reason to go back to the x, because that's the whole point of this, to make life easier. Are we cool, guys? So here we go. Upper minus lower. Square root of 3 squared over 2 minus 0 squared over 2. So square root of 3 squared over 2 is just 3. So 3 over 2. And that's my answer. How do we feel, guys? We're just going to do a whole bunch of these until we get really good. All right, here we go. Let's go to the next one. Here's what you at first you're just looking at it and you're like, man, can I do the antiderivative? Oh, okay, what happened?
Wait, so for your not your limits, but the limits, whatever they're called.
The upper minus lower or whatever. Okay.
How did you? So did you just plug in like the numbers on the other limit?
No, we don't go back to our x's.
No, but for like, how did you find that?
I plugged it into this expression.
Okay,
That's the expression that links u and tan x together. Okay. So look at this one, guys. At first, you're looking at it, and you're like, man, I don't know if I know the antiderivative of that. But we look to see if there's a relationship. I see that the denominator has 1 degree higher than the numerator. Do you guys see that? So then that means that u is probably going to be what? Perfect. So du is equal to 2x dx. I don't have a 2x dx. So what am I going to do? Yeah. Put a 2 there and put a half on the outside. There it is. I color-coded it for good balance, for good notes. What's up? Ask. Oh, because I saw that it was 1 degree higher than the numerator. And I know that the relationship is, if I take a derivative, it's going to be 1 degree lower. You know what I mean? Okay. So check it out. I write 1/2 integral. I'm not going to put the limits. And the 2x dx is going to be replaced with du. I'm going to write it like this. 1 over u du. All right. Side note, because some of you guys made a mistake on this. Side note. Integrand. 1 over x squared plus 3 dx. Don't write this down, just listen. Is the antiderivative of this ln of x squared plus 3 plus c? But you did that on your activity, guys. Why is it not an ln?
Because you don't have to.
No. It needs to be in, okay, so this is not an ln, but this one is. Why is this one an ln and the other one not? I wanted, okay, I guess that's, here's what I wanted. This is linear. This is not linear. The only time it's going to be, the antiderivative is going to be ln, is if you have a linear expression. Okay? All right. So now I got to erase this like this because I don't have the, yeah, you know what Microsoft, well, not Microsoft, this app did? It like locked me out of a whole bunch of features, and I paid for it. I mean, I only paid $5, so it's not like I'm mad, right? But now they want like a monthly subscription. Everything's going to monthly subscriptions, guys. Everything. All right, here we go. Miss Rodriguez, right now, Miss.
Sorry, Joel. So sorry for me. I could come in.
No, it's not.
She was signaling at me.
Yeah. Later on. We're gonna have downtime later on. Okay, here we go. 1/2, I leave that alone. What's antiderivative? Oh, I haven't even done the limits yet. So you guys got me all flustered. Okay, here we go. When x is 0, what is u? -4. Put a -4 down there. When x is 1, I'm looking at this. When x is 1, what is u? -3. So now you can see why we need the absolute values, because ln does not have domain negative values. All right, here we go. 1/2. What's antiderivative of 1 over u? That one you can say ln. Make sure you put absolute value of u. -4 to -3. Are we okay? All right, here we go. 1/2, giant parenthesis, upper minus lower, ln absolute value of -3 minus ln absolute value of -4, close, close. So my answer looks like, this is a side note, ln of A minus ln of B is the same thing as ln of A over B, right? Okay, so this is going to be 1/2 ln. You can, once you take the rid of the, once you already do the absolute values, you can get rid of it. 3, that came out to 3 over 4. Well, why did it come out like that? 3 over 4. Yes. Unless you already have expressions that are going to be positive no matter what. Unless you have an expression, like if you have ln of, you can. It's not going to hurt anything. You know what I mean? Okay. How do we feel, guys? Okay. So here we go. We're going to do, are these the last two? Okay. This is from delta. This is what your first set is going to look like. And here's how your second set is going to look like from delta. And then, so this is what you're going to practice today. And then we'll set you guys loose with UH quizzes in a little bit if we think you guys can handle it. All right, let f be the function such that from -18 to 9 of f of u du equals 3. What must be the value of -6 to 3 of f of 3x dx? Okay, so here's what we want. We want that, right? So I'm going to write integral -6 to 3 of f of 3x dx. So here's what I'm going to write. I'm going to write, on the side, I'm going to write u equals 3x. So that means du equals 3dx. I don't have a 3dx, so I plug in a 3 there, and I put a 1/3 on the outside. Maybe I should use different colors for that. 1/3, there's my 1/3, and there's my 3. So here's what I now have. 1/3 integral. I'm going to have to change my limits in a little bit. F of u du. And I have to change my limits because I'm no longer with the x's. Do you guys see that? So here we go. When x is -6, what is u? All right. When x is 3, what is u? 9. Well, look at this. This right here in black, that right there in black, this told me that it was what? 3. So I have 1/3 times 3, which is just what? 1. Do we see how we did it? Bless you. Sorry for chasing Rodriguez out. I don't know what you were about to sell her or something, but you know. I just wanted to keep going, you know. That's the answer. All right, one more, and then we'll set you guys loose. This one, I look at it and you're like, man, that's ugly. But it's going to get pretty really fast. Notice that inside the square root, there's a third power. And on the outside, there's a second. So obviously, if I take the derivative, it's going to be 1 degree lower. Do you guys notice that? So here's what we're going to do. U, and make it the whole expression. 9 minus 5x cubed. So when we take the derivative, du, the derivative of 9 as a constant goes away. 5 times 3 is 15. So -15x squared dx. Here's what I would do. I would take that 3, or unless you want, no, I would take it out. I was going to say multiply it by 5 and then put a 1/5 or a -1/5. But now I'm just going to take the whole 3/2 out. Is that okay with you guys? All right, so I have 3/2. Look, notice that I'm still writing it in terms of x. So in a little bit, I'll go ahead and rewrite it. X squared, square root of 9 minus 5x cubed dx. What am I going to insert to balance? -15, and on the outside, I'll put a -1 over 15. I guess it would have been better, -5 and -1/5, but no big deal. We already did it. Cool or not cool? All right, so here's what I have. I have a -3 goes into 15 5 times, right? 3, 6, 9, 12, 15. So that is -1/10 integral. And then let's see, I have u. Okay, so always put this one first. Square root of u du. Because I know some of you are tempted to write this. So don't write this down. Just listen real quick. Some of you are tempted to do this. Du square root of u. Tell me why this is wrong. Yeah. So in the math world, du is what marks the end of your integrand. So mark it like this. Square root of u du. Cool? Okay, now we're ready. So here we go. Oh, we're not ready yet. Almost. I need limits. When x is 0, what is u? Do you see how we did that? When x is 1, what is 5 times 1 cubed is 5. 9 minus 5 is 4. There it is. If you want to. Okay, so here's what Abdul Karim is saying. Because she saw that the lower limit is 9 and the upper limit is 4. And she's like, why can't I just switch these limits and make that positive? You can. That's what you're saying, right? So I'm going to write 1/10 integral 4 to 9 of square root of u. You can. That's fine. That's perfectly fine. All right, here we go. 1/10 antiderivative. This is u to the half, so I'm going to put it here on the side. So I'm going to add 1. So it's going to be u to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3 from 4 to 9. Now, okay, and I'm going to slow down. You can factor this 2/3 out. Why? Because both of these terms, you don't write this down, just listen. You can do this if you want, but this is going to take longer, guys. 2/3 times 9 to the 3/2 minus 2/3 times 4 to the 3/2. Notice that the 2/3 is on both of them. Do you guys see that? So can't I just factor it out to make life easier for myself? Yeah, so let's do that. Yes, ma'am. Yes, yes, yes.
Would we be, for this answer, no matter what, like, I guess, value is, would we be guaranteed a negative number?
No, this is going to be a positive number because I have a bigger number minus a smaller number.
Oh, okay, sorry, I didn't see, like, okay.
All right, so here we
I put 9 to 4 and just didn't take out the negative.
No, as soon as I flip the limits, take out the negative, and negative times the negative is a positive.
Okay.
All right, I'm going to factor out this 2/3, guys. 2 goes into 10 5 times. So I see 1 over 15th. Is that what you guys see? 1 over 15th, big. And now go 9 to the 3/2 minus 4 to the 3/2. We can do that. Let's see. 1 over 15. The square root of 9, 3. And 3 to the 3rd, 27. Minus the square root of 4. And 2 to the 3rd, 8. 27 minus 8, 19. So I have 19 over 15. What do you guys think? So now do you think if we just do a whole bunch of practice that we'll be pretty good? All right, guys, that's it. We're done. Now there's just, oh, hello. Who are the ones that missed? Lisbeth, Torres, Tovar, Zoe Lopez. If you guys got all the way to here and you heard this message, go ahead and give it a thumbs up so I know it's real. And come claim your prize. We have cheesecake. So when you swing by, grab a cheesecake. All right, see you guys later. Bye. U equals whatever you have on the inside. Du equals 2dx. I don't have a 2dx, but I force it. If I put a 2 there, I put a half on the outside. So 1/2 integral f of u du. My lower limit. When x is negative 4, 2 times negative 4 is negative 8. When x is 4, 2 times 4 is 8. Right? So I know that's it. There it is. That's it. So now they're telling me that g prime is equal to f. So I can rewrite it in terms of g prime. 1/2 integral negative 8 to 8 of g prime. u du. All right, then what's antiderivative of g prime? G, right? Because that's the antiderivative. The derivative of g is g prime. So 1/2 bracket g of u from -8 to 8. Then we just do upper minus lower. 1/2 g of 8 minus g of -8. See? And then what's g of 8? D. And then what's g of -8? A. So it's just going to be 1/2 d minus a. So it should be that simple. 1/2 d minus 8. So let's see. There we go. Now you probably are getting something like this one, right? Okay. U x squared du 2x dx. We're good? All right. It doesn't have a 2, so I plug a 2 in here, and I put a half on the outside. So now I have this 1/2 integral f of u du. When x is -4, what is u?
That's a crazy number. No, we're like, he's literally messing with us on purpose.
Sorry. Yes. This thing's real sensitive, so it's going in and out. When x is 2, u is 4. Yeah, I'll come back up. We still okay? Now, there it is. Run integral is equivalent to blah, blah, blah. Notice, okay, I guess that's fine. They have a blank space in the front, so that means these two expressions should be the same. So, 1/2, 16/4 f of u du. Sometimes they equal something, sometimes they don't. So watch. On this one, I can just type in, I already forgot. What did I write? 1/2, 16/4. So these two integral expressions should be the same. And there it is. Cool.